Conduit bending is a fundamental skill in the electrical trade. Understanding how to accurately bend conduit, especially when matching existing angles, is crucial for professional installations. Several resources can aid in learning conduit bending, including an EC 358 which addresses raceway bending, relevant sections of the International Building Code, the International Fire Code, and the International Residential Code that cover conduit and raceway bending, and NFPA 70, the National Electrical Code. Matching an existing bend angle requires careful calculation and precise execution. The formula to calculate the distance from the end of the conduit to the bend transition point, the point where the bending starts, is distance L equals leg length LL plus riser R plus setback S. In this formula, LL represents the leg length, which is the distance from the end of the conduit to the start of the riser. R is the riser length, representing the distance from the start of the riser to the desired bend angle. And S stands for setback, which is the distance from the desired bend angle to the center of the conduit. To determine the correct setback, you need to know the total bend angle, TBA, of the existing conduit. Once you have the TBA and the radius of the bend, you can use the formula setback S equals R times the sine of TBA divided by 2. Once you have the setback, you can calculate the remaining parameters. LL equals distance minus R minus S. R equals desired bend angle divided by 2 times R, assuming the same radius as the existing conduit. Proper bender placement is critical for achieving the desired bend. To ensure that the bend center of the new conduit matches the existing conduit, place the arrow on the bender at the distance you calculated for L. This should result in the same bend center location as the existing conduit. Always refer to the manufacturer's instructions for specific bender operation and settings. Practice is key to mastering conduit bending. The more you practice, the more accurate your bends will become. Additional tips for successful conduit bending include: firstly, use a pencil or scribe to mark the start of the bend on the conduit. Secondly, maintain a consistent grip and pressure on the bender handles. Thirdly, follow the bending sequence recommended by the bender manufacturer. Fourthly, check the angle of the bend regularly using a protractor or angle gauge. And fifthly, allow the conduit to cool before handling to prevent damage. Let's delve deeper into the mathematics and practical considerations of matching existing bend angles in conduit installations. The core challenge lies in replicating the bend's geometry accurately, ensuring that the new conduit aligns seamlessly with the existing one, even when the run lengths differ. The formula distance L equals leg length LL plus riser R plus setback S is the cornerstone of this process. Each component plays a vital role in determining the correct bend location and angle. The leg length, LL, is essentially the straight section of conduit leading up to the bend. Its measurement is straightforward, representing the distance from the conduit's end to the point where the bend begins its transition. The riser length R captures the vertical or angled rise created by the bend. This measurement extends from the bend starting point to the location where the desired bend angle is achieved. The setback S is the most nuanced component, representing the horizontal distance from the point of the desired bend angle to the center of the conduit. This accounts for the curvature of the bend and its impact on the overall alignment. Calculating the setback accurately is crucial for precise matching. The formula setback S equals R times the sine of TBA divided by 2 requires understanding the total bend angle, TBA, and the radius of the bend, R. The total bend angle is the angle formed between the original straight section of the conduit and the final angled section after the bend. The radius of the bend, R, is the radius of the arc created by the bending process. It's often dictated by the type of conduit and the bending equipment used. Once the setback is determined, the remaining parameters, LL and R, can be calculated using the formulas LL equals distance minus R minus S and R equals desired bend angle divided by 2 times R. These calculations ensure that the new conduit's bend precisely mirrors the existing one in terms of angle and position. Consider a scenario where you need to match a 22.5 degree bend in an existing conduit run. Suppose the existing conduit has a known radius of 4 inches. To calculate the setback, you would use the formula S equals 4 inches times the sine of 22.5 degrees divided by 2. This calculation yields a specific setback value, which then allows you to determine the leg length and riser length based on the overall distance requirements. When placing the bender, the arrow on the bender should align with the calculated distance L on the conduit. This ensures that the bend center is precisely located, mirroring the existing conduit's bend center. However, it's important to note that different bender types and manufacturers may have slightly different markings and procedures. Always consult the manufacturer's instructions for specific guidance. Furthermore, practical considerations often come into play in real-world scenarios. Obstacles, limited space, and variations in conduit material can all affect the bending process. It's often necessary to make slight adjustments to the calculated values to achieve a perfect match. Experience and careful observation are invaluable in these situations. In addition to the formulas and techniques, the quality of the bending equipment also plays a significant role in achieving accurate bends. Using a high-quality bender with clear markings and precise adjustments can greatly improve the outcome. Regularly inspecting and maintaining the bender is also essential to ensure its accuracy and reliability. Safety is paramount when bending conduit. Always wear appropriate personal protective equipment, including safety glasses and gloves. Be mindful of your surroundings and ensure that the work area is clear of obstructions. Follow all safety guidelines and procedures to prevent accidents. Mastering conduit bending requires a combination of theoretical knowledge, practical skills, and attention to detail. By understanding the formulas, techniques, and safety precautions, you can consistently produce accurate and professional quality bends. The National Electrical Code, specifically Article 358.26, provides guidance on the number and degree of bends allowed in a run of electrical metallic tubing, or IMT. This is important because excessive bends can make pulling conductors through the conduit more difficult and can potentially damage the wires. The NEC generally limits the total bends between pull points to 360 degrees, which can be a combination of quarter bends, offsets, and saddles. Understanding the specific requirements of NEC Article 358.26 and similar sections for other types of conduit, such as rigid metal conduit in Article 344, is critical for ensuring compliant and efficient electrical installations. The 360-degree limit is cumulative, meaning that all bends in a run, including offsets, kicks, and saddles, must be added together. For example, 290-degree bends and 445-degree bends would equal 360 degrees and meet the code requirement. However, exceeding this limit requires the installation of a pull box or junction box to facilitate the pulling of conductors. Conduit fill is another crucial factor to consider when bending conduit. The NEC specifies the maximum percentage of the conduit's cross-sectional area that can be occupied by conductors. This is outlined in Chapter 9, Table 1 of the NEC. Exceeding the conduit fill limits can lead to overheating of conductors, difficulty in pulling wires, and potential damage to the insulation. When bending conduit, it's important to avoid kinking or flattening the conduit, as this can reduce the internal diameter and further restrict the available space for conductors. Using proper bending techniques and equipment is essential to maintain the conduit's integrity and ensure compliance with the NEC. Furthermore, the type of conductors being installed can also affect the conduit fill calculations. Different types of insulation have varying thicknesses, which can impact the overall diameter of the conductors. It's crucial to consult the NEC tables and conductor specifications to determine the appropriate conduit size for the specific application. In addition to conduit fill and bend limitations, the NEC also addresses the support and securing of conduit. Article 358.30 specifies the requirements for supporting EMT, including the maximum spacing between supports. Properly supporting conduit is essential to prevent sagging, damage, and potential hazards. The spacing between supports depends on the size and type of conduit, as well as the application. It's important to consult the NEC and local codes to determine the appropriate support requirements for each installation. Failing to properly support conduit can result in code violations and potential safety risks. The type of fittings used to connect conduit sections is also regulated by the NEC. Article 358.42 specifies the requirements for couplings and connectors used with EMT. These fittings must be approved for the specific application and must provide a secure and reliable connection. Improperly installed fittings can lead to loose connections, water ingress, and potential electrical hazards. It's crucial to use the correct fittings and follow the manufacturer's instructions for installation. Grounding and bonding are essential aspects of electrical safety and are addressed in Article 250 of the NEC. Proper grounding and bonding ensure that metallic conduit systems are effectively grounded, providing a low impedance path for fault currents to return to the source. This helps to protect against electrical shock and reduce the risk of fire. The NEC specifies the methods for grounding and bonding conduit systems, including the use of grounding bushings, bonding jumpers, and other approved devices. It's crucial to follow these requirements to ensure a safe and reliable electrical installation. In addition to the NEC, local codes and regulations may also apply to conduit installations. It's important to consult with local authorities and inspectors to ensure compliance with all applicable requirements. Local codes may have more stringent requirements than the NEC, and it's the electrician's responsibility to be aware of and comply with these regulations. Understanding the NEC and local codes is essential for ensuring a safe, compliant, and professional conduit installation. Continuing education and training are crucial for staying up to date with the latest codes, techniques, and technologies in the electrical industry. The electrical industry is constantly evolving, and it's important for electricians to continuously improve their skills and knowledge. Participating in training programs, attending industry events, and reading technical publications can help electricians stay ahead of the curve and provide the best possible service to their customers. Investing in continuing education is a wise decision for any electrician who wants to excel in their career.